look at boss of the sock. I think we're up to the third one here. Let me check my plan. Yeah, botch part 2. This will be botch part 3. All right, so let's take a look and see what's left to be done here. That means we did the brute force attack. First was the basic information, finding the name of the vulnerability scanner and IP addresses, and the next one was the brute force attack. So let's go down and see sysmon and stream. This is the thing to talk about. So sysmon. Now, if you have a Windows operating system and you don't add anything to it, you have Windows Event Viewer, which records many, many events, thousands per second, and they are very hard to understand and very annoying. Sysmon is a third-party product you install, although now it's from Microsoft. I think it's from sysinternals, and Sysmon will create a small number of events that are far more useful. So if you look at this, yeah, it comes from Microsoft. Instead of having thousands of different kinds of events, all you have is about 20. And so once you install it, you just have an event for process creation, you change the file creation time, a network connection, a process terminated, a driver loaded, very simple, important things. So this has been installed here, and it should be installed on all your Windows servers. It's a free product that makes it much easier to track down this condition of your server, and we're going to see how powerful it is. These sysmon events are quite useful. So where we know that there is an executable file with the name of, I think, 3791.exe that was run, which is the malware the attacker used on the server. And so we want to find that here. In fact, let me go back and let's find the name of the executable to make sure I got it right. I want to get the HTTP events using the post method. So I go here to data summary, source types. I should be able to get HTTP events in the fullness of time. Okay. HTTP events. And now I want post events. And I want exclude events from the vulnerability scanner. I'll put that in first. Not Acunetics. And for the moment, I'll turn on some sampling and make it all time to make the query good and fast. And now I should be able to find the HTTP method down here somewhere. There it is, and get and post are the common methods, so I choose post, and now I'm getting the post methods that did not come from the vulnerability scanner, so I'll go to all time, and I'll get rid of the filtering, which is here. All right, no event sampling. All right, and there are 441 of them. Now, I want to go back to here, and I want to find exe files. So I'll just look for .exe. And I mentioned in passing, as some students were getting confused about this is the database kind of query where you have field name equals value. And that's the most precise and fastest kind of query. Just putting something here like Acunetics or .exe is the grep kind of query where you're just looking for those characters anywhere in the string, which is a simpler kind of search and less powerful and more expensive for the server, but it's the kind we're all used to using on Google, and I use it quite a bit. So you can mix the two, as I've done here. And so now you find two events that refer to .exes. So if I switch this to list, and now I search in browser with Control F, I guess Command F on a Mac, for .exe, then I can see there are several occurrences, and there we are, 3791.exe is, this is the file of something that was uploaded. So that's the name of the malware. That what the person did was they first ran a brute force attack trying hundreds of passwords until they found the administration panel of the web server. Then they uploaded this exe file and executed it on the server. And since the firewalls were not correctly configured, the server was able to make an outgoing connection to a malicious domain called Prank Glassing Fish or something. And we saw that all happen. And it started from this executable. And now we want to investigate more about this executable. So now that I know that name, I'm going to go to this event, bots 3.1. I'm going to find the MD5 hash of that executable. So I already looked at sysmon, and in sysmon, process creation is 1. So when they launched that malware, they have created a new process with that name in it. So it's going to be a sysmon event type 1. So let's go back to a clean search, and let's look at the sysmon events. If you go to your data summary and source types, we were looking at the raw network traffic, which is HTTP, but now we're going to look for the events recorded by Sysmon. And those are here. Win event log, Microsoft Windows, Sysmon operational. And you see there's 270,000 events like that. So I'm going to start with this. And once again, it's defaulted the last 24 hours, which is just as well because I want to put in some filtering before I search for 200,000 events just to save time. So now it'll find 20,000 events, which will be faster. And now I can go down here and look for event ID, which is here. And I want the ones event ID 1. And as you can see, that's only a very small amount of them. These are other things besides process creation, like file creation or something. All I want is the process creation events. So I filter for this being 1. And now I don't need the sampling anymore. So I can see all those events. And I got 41 or 49 events. Let's go back to my tips. So find events for process creation, examine command line to find the correct event. Let's see what kind of fields we have here. Here's command line, and you see this lists the actual event. So one thing I imagine is it'll have the name of the executable on that command line, so I could just, again, do the nasty and just put in a grep type search, where I just want to see these characters somewhere in the event. That should give me the events that launched that process and the events that were related to it. And as you can see, there are 5 such events. You might think there would be only one, but life is never that simple. The reason there are many events, if you look at the command line now, is because one of them actually launched that. One of them launched the CMD, the command process that was going to host it. And here's another one that launched the CMD. This is the thing, when you launch an EXE, first it launches a command line shell to put it in. And it even launches some other Windows process to support it. So, launching one program is not actually just one process. Several related processes are launched. So they were asking for an MD5, and one great thing about Sysmon, since it's intended for security, not only does it log useful events like like a process being created, it adds hashes of the file because it knows you're going to want that. You're going to want to search these hashes to go see if it's known malware or something, or to see if it's identical to another file with a different name. So that's why these log entries are specifically designed for security, so they have very useful information like the MD5 hash. And there's really only 3 of these, and you can just try them until you see which one is right. One of them is the actual file itself. The others are related files that supported its execution. All right, now this stuff we all covered last time, all the things about the brute force attack. And so now, let me do a couple more of these. To find the IP address, there was another part of the attack. Somebody inserted a USB stick and they launched a ransomware attack from that. And it all started from here, which is what we're going to see. So there's a endpoint called We8105 desk. And we want to search for that and look at the source field and look at SMB. So let's see, if I search for this, data that includes the name of that object. I'm going to turn on some sampling because there's a lot of them. All right, so now I have some of those events. Now I want to look for source field. Why do I care that there are 10 values? Oh, these are sources of these events. There's quite a few different sources, different types of data that have the name of that endpoint in it. But what I want is LDAP. LDAP is Lightweight Directory Access Protocol or something. It is the way you log into a Windows domain. Every time you log into a Windows domain, you send LDAP packets around. So this will include the DNS address of that object. So I'm going to turn off the sampling. This is a way to get to a small number of events that are related to that endpoint. And now we can look for streams of LDAP, and we should be able to find events on that day and look at their IP address. So 24 August 2016. If I go look at the date, here we are on 24 August 2016, okay? And I'm trying to find the IP address of this endpoint. So even just looking at this one event will probably do. See, here's a destination IP of 192.168.250.20, and here's the source IP. And by the way, just by tradition, in networking, low numbers at the end are typically servers, and endpoints are typically numbered 100 and then counting up. So this is probably the IP address of that endpoint, that number. Just that is a typical standard. You've reserved low numbers for servers and you assign the high numbers to your dynamically assigned addresses. So I'm pretty sure this is the WE8109 desktop is there. All right, that's a number I think we're going to need as we go ahead here. All right, and now we want to find the malware. So the server ransomware struck, and when ransomware hits, it pops up a box with a Bitcoin address, so it's really obvious. So we can start by just looking for server and go to the source field and guide suricata. So let's find that. If I do server, all right. And then look at the source type is what I like. Here's suricata, and again you can see the FortiGate had a lot of them, the Windows Event Log had a lot of them, the SMB had a lot, but suricata had only a few. And suricata is the intrusion detection system, so it knows what malware is. So these will be the most meaningful events to tell me what happened here. And all right, I want to see which signature alerted the minimum number of times. So there should be something called a suricata signature ID. Let me make sure I got no sampling. Okay, there's only 5 events, and the suricata has some kind of ID down here. Signature ID. Okay, let's see if I can find signature ID. Suricata signature ID. Okay, and there you are. This one hit twice, this one hit twice, and this one hit once. So that's the answer for the flag. And if you want to see what these are, there should be a description of it somewhere. Alert signature. There. Trojan, ransomware server, check-in, onion domain lookup, and check-in. So these are the steps. When you first get infected, it checks in, and then it encrypts all the data, and at the end, it does the lookup. So you can see the time profile here. If you look at the time profile, let's sort by time. I think it's already most recent. Let's see, this is 10:15, and this is 10:15, and this is 9:49. That's what I thought, 9:49 and 9:49. So there's 2 clusters of events. At 9:49, the person stuck in the USB stick and the ransomware was launched. It checked in with home base, telling the home base, I'm encrypting these files. And then it started encrypting the files. It took about half an hour to do it, and by 10:15 it was done, and it's popping up the ransomware saying your files are infected. So this is the time period of the ransomware infection. You can see it right there from suricata. All right, and so I want to see where it went to call up the ransom note. It went on the hidden on the Onion Tor network to do it. So what I'm going to do is find suricata and look for the Onion domain lookup, which is going to be easy from where I am. I already have that here. If I go to the suricata alert type here, signature, not the ID, but I had it a minute ago, the signature itself, there. Here is the Onion domain lookup. That happened when it was time to present the ransomware data. So if I click on that, I have the 2 events of Onion domain lookup, and notice they're all both at exactly the same time. 10:15, 12.668, down to the millisecond, they're the same time. So what I want to do, there was an Onion domain lookup at this time. I want to find that Onion domain lookup. So I want to look at the DNS lookups at this time. Now, DNS is one of the most common protocols. There are hundreds of DNS lookups every second on a busy network. So you need to have it very limited in time. The easiest way to do it is to click this time and now limit yourself to plus or minus 1 second. That's an easy way to narrow right down to a really short period of time near there. And I know it's working because I can still see my 2 suricata events. Now I just want to change the type of event from suricata signature and server. I want to change it to stream type DNS. And I'm just going to type it in, see if I can get it right. I probably can't get it right. I'm going to go, I'm going to take a look here to see how it's right at the top of this. We did it with stream type HTTP. I just want to get the format right, and I don't want to lose my time sampling. So I'm going to find an example here. There. Source type equals stream : HTTP. That's what it looks like. Let's start from this. I just don't like to type in things I'm going to get wrong. So instead of any of that, I'm going to have this, but I'm going to change it to DNS. So I'm going to see all the DNS events for this 2-second period. And there were 16 of them, 16 things looked up there. And if I look at the thing that was looked up, which is going to be host name, maybe not host name, let's take a look and see if my tips are going to tell me. Look at this query field. All right, the query is what it's trying to look up. Here's the queries. All right, and now you can see these are innocent. Microsoft something, Bing. This is obviously the malicious one, the one that looks really funny, and it even has Cerber in it, which is the name of the ransomware. So that's the malicious name that was looked up to load the ransom note off the dark web. All right, and I think that's, I'll just mention this VB script one. If you look for a VB and EXE, you can find the malicious script itself. And so I think that's all you need. Yep. So if you want to see the actual script that was used to perform the ransomware, all you need is .vbs and .exe. And go to all time again, outside that 2-second range. And there's only 16 events like that. And look at the body field here. And here you can see a new process was created and a C script, no logo. And this looks normal. The malicious one is extremely obvious. There, this is the one that's malicious. You can tell because it's obfuscated. Everything has these ridiculous names like GNBIPP. That's how you obfuscate code. You change all the names to unreadable garbage. You have strange capitalization. This is not normal code. This is the malicious code. So that's the Visual Basic script that performed the ransomware attack. All right, that's what I wanted to show you now. I think that's enough for the second batch here. Let me stop the recording. What's that? Yeah, to get the character count, you have to do pipe count field equals something like that. I've forgotten. We did it before, and I've already forgotten how to do it. Do you remember how to do it?
Well, what I was doing was I just used a character counter, like a separate website.
A separate, okay, I didn't try if that works at all. Yeah, inside Splunk, yeah, the next one you have to get the actual field length, and I thought I had an example of how to do it here. It's a little hard.
I didn't find that to be
That's why this one is for 15 points. This one is pretty annoying. Length of field, I think, and yeah, eval, L equals length of field, table L. This combination works to give you the length of a field. So for example here, let's try it, now that we're here, since that's the next one. So this body field, was it the body that had it?
It's in the body.
Yeah, but it's extra junction in the body, isn't it? Like the new process has been created. There's another field that has just the script, right? What's that?
I think you have to go into raw view.
Right, yeah, it's parent command line or something, as I recall.
Yes, exactly, yes.
Yeah, so if you go down here, there's a field called parent command line. Yeah, that's got the actual script itself with no extra junk in it. And so if you want the length of this field, it's going to be like this, and this has to be parent command line. I think that will do it.
You don't need a pipe in front of the eval? No.
Oh, I do need a pipe before eval, thank you. There we go, now I get some lengths. And I think the longest one here is the right length. So this is the way inside Splunk you calculate the length, but you can just copy it into something else, like a FX file and use a Unix command to count it or something, or Notepad or anything, yeah. All right, well, that's enough of these demos for today, I think. I'm going to stop.